Bismillahirrahmanirrahim. My dear students, here is your mathematics teacher Muhammad Amjad Saeed from Pakistan International School, Taif, Saudi Arabia. Today we will continue our lecture number 50 and inshallah we are going to have our chapter number 16. In chapter number 16 we have received revised reduced syllabus, and in revised reduced syllabus we are given theorem number 16.1.1 in this chapter, and after that we have review exercise and one question from exercise 16.1. So theorem number 16.1 statement is parallelogram on the same base and between same parallel lines. Parallelograms between same base and having the same parallelogram on the same base and between the same parallel lines. Between same parallel lines are equal in area. Are equal in areas. Remember that, first of all, you must understand we are given a parallelogram. There are two parallelograms with same base and between same parallel lines. This is given. Are equal in areas. This is to prove. So we have parallelogram like that. Here is A, B, C and D. A, B, C and D. Then we have another parallelogram, that is A, B, E, F. This is E, F. Dear students, what is given? Two parallelogram A, B, C and D and A, B, E, F have same base as AB. Two parallelogram A, B, C, D and A, B, E, F are on the same base, that is AB, and between the same parallels, between the same parallel lines AB and DE. Again, I am repeating what is given. Two parallelogram ABCD and ABEF have same base AB and between same parallel lines AB and DE. To prove is area of parallelogram ABCD is equal to area of parallelogram ABEF. Again, to prove area of parallelogram ABCD and area of parallelogram ABEF. So dear students, you can check. We have two parallelograms, and remember that in both parallelograms ABED, this is common quadrilateral. If one way or another way, we can find that area of triangle EBC an area of triangle FAD, then both parallelogram will have same area. This is the key point in your theorem. Remember that ABED is quadrilateral, which is present in parallelogram ABCD. Similarly, in parallelogram ABEF, ABED, again this is quadrilateral, which is present in ABEF also. So this is common in both parallelograms. If one way or another way we can prove that triangle with have area EBC is equal to area of FED, then definitely both parallelogram will have same area. So dear students, in proof we can write down area of parallelogram ABCD is equal to, in proof, remember I am not writing given and to prove because they are oral. I have told you, and you can consult your mathematics book so you can have better idea about this. So I am writing down only that important part of your theorem. Statement and reasons. This is the main body of the theorem, remember that. You know, area of parallelogram ABCD is equal to area of quadrilateral ABED plus area of triangle EBC. You know that here is addition of area axiom. Area of parallelogram ABCD is equal to area of quadrilateral ABED plus area of triangle EBC. This is number 1. Area addition axiom. Okay. Similarly, area of parallelogram ABEF is equal to area of quadrilateral ABED plus area of triangle FAD. This is number 2. Remember that I have already told you that area of parallelogram ABCD is equal to area of quadrilateral plus area of triangle. Area of parallelogram ABEF, that is equal to area of quadrilateral, the same one, and area of FAD. Remember that this area of quadrilateral is same in both. This is same in both. So that's why the very important thing is that we have to prove that area of triangle ABC, if area of triangle ABC is equal to area of triangle FAD, then definitely both areas will be equal. So in the correspondence of triangle EBC and triangle FAD, here will be BC is congruent to AD. Remember that these are the opposite sides of parallelogram. Opposite sides of parallelogram. Similarly, BC is congruent to AD and BE is congruent to AF. BE is congruent to AF. Again, opposite sides of parallelogram. Opposite sides of parallelogram. opposite sides of parallelogram. After that, we have angle CBE. Angle CBE is congruent to angle FAD. As you know that this side is parallel to this side and this side is parallel to this side, FA. So that's why these are the corresponding angles, they are congruent. Therefore, triangle EBC is congruent to triangle FAD, that is side angle postulate. Dear students, remember that whenever the two triangles are congruent, it means that their sides are congruent, their angles are congruent, and the portion covered by both triangles will also be congruent, that which means that area will be congruent. Hence, therefore, area of triangle CBE is congruent to area of triangle FAD. So if you have these two triangles equal, these two triangles with equal area, if you add them here, then from 1 and 2 you can say that hence area of parallelogram ABCD is equal to area of parallelogram ABEF. Dear students, that was your theorem number 16.1. After that, we have exercise 16.1. And in exercise 16.1, we have question number 2. In a parallelogram ABCD, AB is equal to 10 centimeter. The altitude corresponding to sides AB and AD are respectively 7 and 8. Then find AD. Here is we are going to solve it. Question number 2, exercise 16.1. Exercise 16.1. Question number 2. We have in a parallelogram ABCD, question number 2. In a parallelogram, this is A, B, C, and D. Remember that in a parallelogram ABCD, AB is equal to 10. This is 10 centimeter. AB is equal to 10 centimeter. The altitudes corresponding to sides AB and AD. AB, this is altitude corresponding to side, and here is altitude also. This is altitude and this is altitude. What is altitude? Altitude is the line segment which is perpendicular on a side from opposite vertex. This is vertex, this is perpendicular on this side AB. Similarly, this is vertex and it is perpendicular to side AD. So what is given? ABCD is a parallelogram, and here is, you can say this is P and this is Q. What is given? ABCD is a parallelogram in which AB is equal to 10 centimeter. AB is equal to 10 centimeter. And altitude corresponding to that, this is DL DP. This is PD. What about PD? PD is equal to 7 and BQ is equal to 8. This is 7 centimeter and this is 8 centimeter. Dear students, you know that we have to find AD to prove. To prove is AD. We have to find AD. What is the area of parallelogram? Remember that. What is the formula for area of parallelogram? What is formula of area of parallelogram? Area of parallelogram is equal to base into altitude, mean perpendicular height. So you can have area of parallelogram is equal to base into altitude. So what about the base? If base is AB and altitude will be PD. Therefore, base AB into altitude is PD is equal to base is AD and altitude is BQ. Remember that AB is 10 centimeter, PD is 7 centimeter, AD is unknown and BQ is 8 centimeter. So AD is equal to 10 into 7 centimeter square over 8 centimeter. So what will be that? Length of AD will be equal to 70 over 8 centimeter, which will be equal to, divide that, 8.75 centimeters. So dear students, that was your question of exercise 16.1. You have applied that formula. This is the formula, base into altitude. So AD is base and altitude is BD. Here AD is base and altitude is BQ. In this stage we have found unknown values. After that we have, dear students, we have finished our chapter number 16. Now I am moving to this review exercise 16. Which of the following true and which are false? Area of figure mean region enclosed by bounding lines of closed figure. Yes, it is correct. Similar figures have same area. No, similar figures have different sizes, so their area will never be same. Congruent figure have same area. Yes, of course. Congruent figures will have same areas. A diagonal of parallelogram divide into two non-congruent triangles. No, it is not non-congruent. It is congruent triangles. So it is false. The correct option is a diagonal of parallelogram divides into two congruent triangles. Altitude of triangle means perpendicular from vertex to the opposite side. That is base. This is the definition of altitude. Definitely it is correct. Area of parallelogram is equal to product of base and height. Yes, it is correct. After that we have question number 2. Find the area of following. We have already finished that. So dear students, we are moving to our last exercise chapters and we have exercise 17.1 and Alhamdulillah we did this exercise 17.1. Question number 1 and 2. You can solve remaining question from 1 and 2 because they are exactly similar. But here in In question number 3 and 4, yes, of course, they are different. So we can draw exercise 17.1, question number 3 and 4. Chapter number 17. Chapter number 17. Exercise 17.1, question number 3. Question number 1 and 2, you have better idea about this. You can draw the triangles, no problem, you can do it. But question number 3 and 4, they are different, a little bit different side. So that's why we can do it. Construct a right angled measure of triangle whose hypotenuse is 5 centimeter and one side is 3.2. Construct a right angled triangle whose hypotenuse is 5 centimeter. Question number 3, right triangle. You have to draw right triangle whose hypotenuse is equal to, yes, is equal to 5 centimeter and one side is 3.2 centimeter. Dear students, now you can draw this right angle triangle with hypotenuse is 5 centimeter and one side is 3.2. First of all, you will draw a line segment that is 5 centimeter. Suppose this is AB. Draw a line segment AB of length 5 centimeter. Draw perpendicular bisector of AB. Put your compass at A. Open the compass more than half and draw 2 arcs. Put your compass at A and draw 2 arcs above and below by opening your compass approximately more than half. Similarly, with the same opening, put at B and cut them. So this will be perpendicular bisector of your side AB. Dear students, this is the midpoint of AB. Suppose it is O, take O as center, open the compass equal to OA or OB and draw semicircle. Draw semicircle. Draw a line segment AB of length 5 centimeter. Draw perpendicular bisector of AB by opening more than half compass. Then this O will become midpoint of AB. Taking O as center, draw a semicircle of radius OA or OB. After that, open the compass equal to 3.2 centimeter. Taking O as center, draw this arc which will cut this semicircle at point C. Join C with A and C with B. Dear students, this is your right angle triangle ABC where 90 degree is at C. So opposite to 90 degree, you know that this is always hypotenuse. So this is hypotenuse. This is hypotenuse, 5 centimeter hypotenuse. So this is the question. After that, question number 4. Construct right angled isosceles triangle whose hypotenuse is given. Remember that we have 2 parts and they are exactly similar. And remember, in question number 4, right isosceles triangle. You have to draw right isosceles triangle whose hypotenuse is number 1, hypotenuse is equal to, we have 5.2 centimeter. 5.2 centimeter. Dear students, very easy. Again, you take a line segment 5.2 centimeter, that is AB. Draw a line segment AB of length 5.2 centimeter. Open the compass more than half, draw two arcs above and below. Similarly, by taking at B and then join them. That will be the midpoint of AB. Here is AB. Midpoint of AB, that is O. Taking O as center, draw an arc of radius or rather semicircle of radius OA or OB. Draw a line segment 5.2 centimeter long. Draw a perpendicular bisector of AB. Suppose it is LL dash. It cuts AB at point O. Taking O as center, draw a semicircle of radius OA or OB. This semicircle cuts this perpendicular bisector at point C. Join C with A and C with B. Dear students, these two sides are equal in length. So this is isosceles triangle, and at C this is 90-degree angle. So this is ABC, a right angle triangle. After that, exercise 17.2. Yes, exercise 17.2. I hope that you can solve these questions. We have already solved one part from each question. So you will have the idea, you can do it. Now we can take our exercise 17.3. Remember that in 17.3 there are two questions. And dear students, I am solving one question for you and one you can do by yourself. And after that we will move to our exercise 17.4. In 17.3 I am taking first part. Remember that in 17.2 we have already solved one part from each question. So you have the idea about the median, about perpendicular bisector of sides, or about the altitudes, etc. So you can draw with the help of these examples, but I did that already. Exercise 17.3. Question number 1. What is given in question number 1? Construct a quadrilateral ABCD. Construct a quadrilateral ABCD. Quadrilateral ABCD, in which AB is equal to AC is equal to 5.3 centimeter. Then BC is equal to CD is equal to 3.8 centimeter and AD is equal to 2.8 centimeter. Part number 2 is on side BC. On side BC. Construct a triangle equal in area to parallelogram, to quadrilateral. Dear students, basically we have the hint in the question already. In question number 1, in part 1, quadrilateral ABCD, this is given data, we have to draw this quadrilateral. But in second part, they have given us this idea what can be taken as a base. Here is BC, on side BC, construct a triangle. Remember that I am taking BC. This is BC. BC is 3.8 centimeter. Remember that. BC is 3.8 centimeter. After that, taking B as center, draw an 5.3. Remember again, taking B as center, draw an arc of radius 5.3 centimeter, and taking C as center, draw another arc of radius 5.3. Now join them. Remember that this is 5.3 centimeter, this is 5.3 centimeter. This point is A. Check that BC was given. This is a hint here. Here there is a hint. Take BC as a base 3.8 centimeter. Taking B as center, draw the arc 5.3. Taking C as center, draw the arc 5.3 centimeter. They will cut each other at point A, join A with B and C. After that, taking C as center, draw an arc of 3.8 centimeter. Remember that taking C as center here, taking C as center, draw an arc of radius 3.8 centimeter. 3.8 centimeter. And taking A as center, draw an arc of radius 2.8 centimeter. This common point is D. Join A with D and C. Dear students, this is your quadrilateral A, B, C and D. This is the quadrilateral ABCD. Now we have to draw. Look at that. Extend this CB up to point X. Extend this CB up to point X. And here join B to D. Join B to D. And now you can have, remember that this angle equal to this angle. These two angles are congruent, alternate angles are congruent because they are parallel line. Here, open the compass equal to AD and taking B as center, draw a point P on CB produced. Join A to B with dotted line. So BD is parallel to AP. BD is parallel to AP. Again listen, extend CB up to point X. Now draw B and D. Open the compass equal to AD, taking B as center, then draw the arc which will cut at point P. Join A with P. Now P and D are joined with the solid line. Your required triangle is PDC. Your required triangle is PDC, whose area is equal to quadrilateral ABCD. Remember that this portion is out of this triangle, but this portion which is equal, it is added in this triangle. So that's why both will have the same area. I hope that you understood this question. Dear students, after that we have exercise 17.4. Inshallah we will do it, and along with your review exercise 17, and we will finish it. Inshallah we will finish the syllabus once again with the revised reduced syllabus. Okay, Allah Hafiz and Assalamu alaikum wa rahmatullahi wa barakatuh.